This video shows how to take your raw data from the NSA R110 lab with the shots and with temperatures, do calculations from that raw data, and graph it with Excel. This is our raw data here. These are the milliliters, and this is the mass in grams. Notice that we don't write the unit in, because if we write the unit in, Excel will not recognize that as a number. Also, the milliliters is supposed to be 11.0, not just 11. But if you try to put in 11.0, Excel will read that as 11, as just 11. So to force it to put the zeros in, we'll highlight these cells, go over here to where it says increase decimal, and then go to where it says decrease decimal to bring it down to 1 decimal place. That's for the milliliters. For the grams, we need 2 decimal places, so we highlight these cells here, bring it up here to increase the decimal places, and if it's too many, we'll decrease it, but here it's just right. Now we're going to do some calculations. The first calculation we'll do is the volume of just the shots. To get the volume of just the shots, we'll have to take each of these volume readings and subtract them from the first one, because the first one had no shots. This was 15, this was 30, and this is 45. Notice I didn't actually put the shots in there because they're not part of the graph, but you can if you want. So the milliliters of shots over here, we will write this as equal A2, that's the data cell that we're using, minus $2. We're going to subtract each of them subtract the first one from each of them. That $sign is the cell to be the same one each time. The $sign means leave it alone. Hit enter, and we get the expected 0.0. Then we'll do the rest of them. To repeat the calculations for the rest of them, we'll highlight the lower right-hand corner where the little dot is. Notice that the cursor becomes a skinny plus. Click and drag down to the other cells, and then let go. And you get the expected numbers. Now, if you click on another one, you'll see that here on the formula bar here, it says A3 minus $2. This is A4 minus $2. This is A5 minus $2. That should make it clear what the $sign does. Now we're going to do the same thing for the mass. This is the mass of just the shots. The 56.5 was the mass of the water and also the mass of the graduated cylinder, so we're going to subtract that from each of the others. Equals B2, that's the cell that we're starting with, minus the cell we're subtracting, which always has to be the same cell, the $2. Hit return, click on the cell one more time, go to the bottom right-hand corner where the skinny plus is, click and drag. And that's the mass of the shots. Now we're ready to make a graph. We will highlight C and D, highlight the entire column, and then we're going to put up here at the top, insert. And then under charts, we're going to go way over to here where it says scatter, XY, or bubble chart. Click on it and click just the plain old scatter, not with any lines in between. We'll have the line later. So there's the scatter plot. You notice that the axes don't have labels, and the chart title is it just says mass of shots, which is the y-axis. Let's go ahead and add some titles to these axes. This one's a little hard to find here. We're going to add chart element up in the upper left-hand corner, and then axes titles for the primary horizontal axis. We'll click there, and then we'll rename this, highlight it, and this will be the volume of shots. And then I'll put the units, milliliters. Click somewhere else to enter it. Then we'll do the same thing for the vertical axis. Add chart element, axis titles. Primary horizontal now is green because we have a title now. Now we go to primary vertical axis. And then we're going to highlight, use the up and down arrow to highlight here. And this will be mass of shots in grams. And don't hit return, but just click outside. Now we're ready to add a trend line. The trend line is what is Excel speak for a line of best fit. Go back to add chart element. Down here where it says trend line, and then without clicking on it, you'll see there, just by hovering the mouse over it, you'll see the options. Go straight down where it says more trend line options, because we're going to need to go through these options in some detail. Now, in these trend line options, sometimes it might be over here. This is the fill of the line. This is what the line looks like. I'm not going to worry too much about the appearance of the line. I'm more interested in the equation. So we'll click over to here where it says trend line options. And we see linear selected, which is what we want. But there's a couple things we need to change. First, we're going to force the intercept to go through 0. So we're saying set intercept, click on that. Remember the equation of a line, y equals mx plus b. This one we expect to just be y equals mx. And that's because when there were no shots in the water, before we added any shots in, we expected the volume and the mass to both be 0 exactly. So we're going to force those to be 0. Now we just need the equation on the chart. The equation is over here. Y, which is the mass, equals 6.2355 x, which is the volume. Therefore, that 6.2355 represents y divided by x, or mass divided by volume. In other words, the density. So we just measure the density of the shots. We measure the density not by doing one measurement, but by doing 3 different measurements and doing a type of average between them. So this is a good way to get a handle on what the density of the shots were. We know the shots were probably not made of lead because lead would have a density of about 11. The other option here is to display the R-squared value, so we'll check on that as well. The R-squared value is a measure of how close to a linear fit your data is. A perfect linear fit would be 1. We see this is pretty close, 0.9573. Now we're going to click over in a different tab and put the data in for the temperatures. These were some data from one of your classmates. These are temperature data here. These are different temperatures. Putting the thermometers in hot and cold water and measuring the temperature in Celsius and measuring the temperature in Fahrenheit. Here we don't need to do any calculations. We're just going to add a chart. So we'll select on A and then drag over to the header for B. Let go. Go to Insert. Go to under Charts, over here, the scatter plot. There's the scatter plot. Select that. And just as before, we'll add a trend line. Before we add the trend line, let's add axes to this. This chart title doesn't make a lot of sense. I'll double click that and do some editing here. This is, I'll call it temperature data maybe. Click on to enter it. We'll add some axes because the axes labels are important. Add chart element, axis titles, primary horizontal. This was the lower temperatures, a lower number, so we expect this to be the temperature degrees Celsius. Temperatures, degrees Celsius. Now you might be wondering, how do you put that degree symbol in? This is how you do it on a computer the quick way. If you have a PC, hold down the Alt key. That's the key that's next to the space bar. Hold down the Alt key And then on your keypad, not on your number pad on the very right side of the keyboard, not the numbers on the top of the letters, but the number pad on the right of the keyboard, type in 0176. Then let go, and there's your degree symbol. So Alt, hold down Alt, and then 0176, and then let it go. So that's degrees Celsius. Click out. Add chart element. And that's going to be your, and then for the chart element, we're going to add the axis titles, the primary vertical axis. Click there. And then here, this is going to be temperature. And then the parentheses, degrees Fahrenheit. Alt 0176 Fahrenheit. I forgot to put the temperature parentheses here, so let's put that here. Click out. Okay, now to add a trend line, just do the same thing you did before. Add chart element, add trend line, more trend line options. And then for here, we're going to add, click over to where it says trend line options, not the bucket thing, but the trend line options. And then go linear is fine. We're going to display the equation on the chart as before, display the r squared value. But this time, we're not going to set the intercept to 0. We're going to let the intercept be whatever it fits best to be, because we know that 0 degrees Celsius and 0 degrees Fahrenheit are not supposed to be the same temperature. Notice the equation, y equals 1.7811x plus 32.114. Now you know the formula for degrees Celsius, degree Fahrenheit. Degrees Fahrenheit is 9/5 degrees Celsius plus 32. 9/5 is 1.8. Notice that the 1.7811 is pretty close to 1.8. And of course, the 32.114 is pretty close to what it's supposed to be, which is 32. The r squared value, if it's ideal, is 1, and you see it's pretty close. To submit this, there'll be a place on Canvas to submit this graph, so you won't have to print this out. Thank you so much.